Welcome back once again to our discussions, and thank you for always joining us. We are once again presenting a question that was done in KCSE 2001, paper 2, question number 15, a question on trigonometry. And the question we have read: solve the equation 4 sin squared theta plus 4 cos theta is equal to 5 for the range of values of theta between 0 degrees and 360. We are first going to start by bringing our quadratic identity, which states that if you take the cos squared theta plus the sine squared theta, this one will always give you 1. Having done that, we proceed by making the sine squared theta the subject of the formula. And in this case, the sine squared theta will be equivalent to, if we move cos squared theta to the other side, we are going to have 1 minus cos squared of theta. Once we have done that, we can now bring down this equation, and anywhere you see sine squared theta, we are going to place 1 minus cos squared theta. In this case, we have 4. We multiply by the sine squared theta is the same as 1 minus the cos squared theta plus we have 4 times cos of theta, and this one is going to be equal to 5. We can open the bracket by taking 4 times 1, which is 4. Then 4 times minus cos squared theta will give us minus 4 cos squared of theta plus 4 cos theta. If we bring 5 to this other side, it becomes a minus 5, and this one is going to be equal to 1. Once we have done that, these 4 and 5 can be combined such that 4 minus 5 will give us 1. We are going to remain with minus 4 cos squared theta plus 4 cos theta. This one is going to be equivalent to minus, that is cos theta, minus 1. This one is going to be equal to 0. If you divide all through by negative 1, we are going to have 4 positive, that is 4 cos squared theta, then minus 4 cos theta plus 1, and this one is going to be equal to 0. At this point, we can simply let cos theta be equal to y. And if cos theta is y, then cos squared theta is going to be cos times cos, giving us y squared. So we are going to have 4y squared here, minus 4 times cos theta is y, plus 1, and this one is going to be equal to 0. This is a quadratic equation, and therefore we can use product sum method. Using product sum method, we are going to have 4y squared minus 4y plus 1 being equal to 0. Remember, the product is going to be obtained by taking the coefficient of the quadratic term, which is 4 times 1, giving us positive 4. Then the sum is going to be equal to the linear term, that is the coefficient of the linear term, which is 4. For now, we are now going to proceed by getting the factors whose product is 4 and their sum is negative 4. The two factors are negative 2 and negative 2. Then we use the same factors and bring them into our quadratic equation, but the two factors are going to replace the linear term. That means we are going to have 4y squared. Instead of the middle term, we are going to use minus 2y plus 1, and this one is going to be equal to 0. We can now factorize the two in pairs. Between 4y squared and minus 2, 2y is common into 2y minus 1. Then we come to minus 2y plus 1. 2y minus 1 is common. Then we place negative 1 outside, such that we are going to have 2y minus 1 into 2y minus 1, and this one will be equated to 0. Having done that, remember the two brackets are the same, meaning 2y minus 1 is equals to 0. Y is going to be equal to 0.5. That is, if you move minus 1 to the other side, it becomes a positive. Then you divide by 2 on both sides, you get the value of y. Once we have gotten the value of y, since this was cos, we are going to get the cos inverse of 0.5, and the cos inverse of 0.5 will give us 60 degrees. You can press your calculator. That is the cos inverse of 0.5, that is exactly 60. Once we have gotten that, we now go to the unit circle. We do a sketch of the unit circle. You can also use a sketch of the unit circle this way. We have 0, we have 90, we have 180, we have 270, we also have 360 degrees at this point. Remember, all angles in the first quadrant are positive. Only sine in the second quadrant is positive. Only tan in the third quadrant is positive. And only cosine in the fourth quadrant is positive. Since this is an acute angle, it is going to fall in the first quadrant. So we measure 60 degrees from 0 in the anti-clockwise direction. And again, cos is positive in the fourth quadrant. And therefore, we are going to measure again 60 degrees in the clockwise direction from the horizontal line and mark this as 60 degrees. So once we have done that, we can now get the range of values of theta that fall within the given range, that is between 0 and 360. Remember, the first angle, theta, will be equal to, from 0 we are going to measure 60 degrees. Then the next one is going to be measured from 0 degrees all the way to this point here. That means to get the angle in the fourth quadrant, we simply take 360 minus that particular angle of 60, giving us 300 degrees. Therefore, the value of theta will be 60 and also 300 degrees. These are the two angles that are going to satisfy the given range. Otherwise, if we continue again from 720, we add 60, we are going to have 780, which is going to be above the given range, and that gives us the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.